As part of our series exploring Honeywell Computers, we highlight some of their early digital computing systems. From 1957 to the mid-1980s, Honeywell was highly involved in digital computer manufacturing. Honeywell's first large computer was the DATAmatic 1000, released in 1957. The DATAmatic 1000 was a giant machine, using a modular logic board design for easy maintenance and over 3,600 vacuum tubes and 500 transistors. It was famous for its 3-inch wide magnetic tape reels. The DATAmatic 1000 was created by DATAmatic Corporation, established in 1954 as a joint venture between Raytheon and Honeywell. In 1953, Raytheon Company had produced the giant RADAC computer for the U.S. Navy. RADAC was a first-generation machine, using 5,200 vacuum tubes and 18,000 crystal diodes. Honeywell bought out Raytheon's share of DATAmatic Company and renamed it Honeywell DATAmatic. Honeywell's goal was to become a major player in this market as well, which was being dominated by UNIVAC and IBM. Honeywell was one of the 7 large computer makers that were in competition with IBM. The news media referred to this group as Snow White and the 7 Dwarfs. IBM was called Snow White because it controlled 70% of the computer market. The 7 competing companies were Burroughs Corporation, Control Data, General Electric, Honeywell, National Cash Register, RCA, and UNIVAC. By late 1971, both GE and RCA had left the mainframe computer business. The remaining group was nicknamed the Bunch: Burroughs, UNIVAC, NCR, Control Data, and Honeywell. Then, in 1966, it acquired Computer Control and its popular DDP line of minicomputers. Computer Control was founded by former engineers and staff of Raytheon Company. It became Honeywell's Computer Control division. In 1970, it acquired General Electric's computer business. Next, Honeywell acquired Xerox Data Systems' Sigma computer line in 1975. The Sigma line had previously been obtained by Xerox when it acquired Scientific Data Systems, SDS, in 1969, and rebranded its computers as the XDS Sigma line. Honeywell's next major large-scale computer was the Honeywell 800. What you are looking at is a rare film clip of the Honeywell 800 mainframe. Introduced in 1960, the Honeywell 800 marked the company's first large-scale, fully transistorized mainframe. Designed for both business and scientific work, it featured a 48-bit word length and a modular magnetic core memory, expandable from 8,000 to 30,000 words. Its cabinet-based design reflected the style and precision of early 1960s computer engineering. The internal logic circuit racks were modular for easy maintenance. The 800's logic circuits used nearly 6,000 transistors and 30,000 diodes. Cycle time was about 3 microseconds. It could execute 40,000 instructions per second, which was quite fast for its time. The 800 could handle both binary and decimal operations, as well as optional floating point math for scientific applications. A unique feature was the executive scheduling and control subsystem that enabled multiple independent programs to be executed in parallel without requiring manual intervention for each job. Honeywell called this automatic parallel processing. Up to 8 programs could be run concurrently. The Input-Output Control Center managed a wide range of peripherals, including magnetic tape drives, printers, and card readers. Although it was smaller than some of the earlier vacuum tube giants of the 1950s, the Honeywell 800 filled an entire room, displaying tall frame cabinets housing the processor logic and memory, and separate operator control panels illuminated by rows of indicator lights. The following chart shows the requirements for electrical power and floor space, as well as the purchase cost and rental amount for a basic system. Between 1960 and 1964, a total of 89 systems were made. The following is a listing of some known customers of the 800 system. Honeywell models 1800 and 1800-2 were improved and expanded members of the 800 family and looked very similar. Additional computers offered during the 1960s included models 200, 300, and 400, and support for digital data processor DDP microcomputers, such as the DDP-224 and others. The DDP-224 was a 24-bit transistor-based minicomputer originally developed by Computer Control Corporation in 1965. After 3C became part of Honeywell Information Systems, the DDP-224 line continued under Honeywell's Computer Control Division until the early 1970s. One of the most notable early users of the Honeywell 800 was the Ames Research Center, one of the core NASA research centers. Around 1961, Ames procured a Honeywell 800 in conjunction with a smaller Honeywell 200 computer, which served as its front-end processor. The 800 had a single mission-critical application, that of online wind tunnel data reduction. The 800 was selected specifically to replace the older, slower Electro-Data Datatron computers, which could no longer manage the high-volume data streams from Ames aeronautical research facilities. The Honeywell 800 was a pivotal, long-serving, and highly specialized component of the computing infrastructure at Ames. The 800 was not a general-purpose scientific machine, but rather a specially designed, high-throughput data processor, procured specifically to solve the critical wind tunnel data analysis. The primary advantage of the 800 was its ability to process several streams of data through multiple concurrent programs. This was an advantage over a competitor machine of the time, the IBM 7090. The 800 was far less costly to rent, averaging around $20,000 per month compared to over $60,000 per month for IBM's giant 7090. The 800 had an exceptionally long 16-year life at Ames, from 1961 to 1977. It served as a bridge from the early data collection systems of the 1950s to the emergence of the large time-sharing systems and supercomputers that would later define Ames' impressive reputation in computational fluid dynamics. By the end of the 1970s, the Honeywell 800's tasks had been migrated to an IBM System 360 mainframe, which was itself replaced in the early 1980s by high-powered DEC VAX systems, followed by a succession of increasingly more powerful computers and supercomputers. We have listed most of these in the appendix at the end of this video. Several DDP-224 units were used in the mid-1960s in the Gemini program and early Apollo program astronaut trainer simulators. The DDP-224 was a 24-bit transistor-based minicomputer originally developed by Computer Control Corporation in 1965. After 3C became part of Honeywell Information Systems, the DDP-224 line continued under Honeywell's Computer Control Division until the early 1970s, performing real-time simulation and spacecraft computer emulation, enabling astronaut crews to train in high-fidelity digital simulation rather than purely analog systems. In its role supporting NASA, in parallel to the digital computer line, Honeywell supported major NASA programs from Gemini and Apollo through Centaur upper stage missions, supplying avionics, environmental controls, guidance, and inertial systems. After Honeywell Bull was formed in 1987, Honeywell exited the large computer manufacturing business fully by 1991. After 1989, Honeywell Bull was known as Bull HN Information Systems Incorporated, and no longer included Honeywell in its name. And today, Honeywell International Incorporated, in addition to its many excellent products and services, remains a major NASA supplier in many technical areas, such as navigation, avionics, actuators, and ground systems.
What's ahead for electronics? Here with some predictions is James H. Binger, president of Honeywell.
The electronics industry is looking forward to major gains in the year ahead, especially in business and industrial computers, industrial controls, miniature circuits, and color television. The nation's defense program requires more and more electronic equipment, and there are promising markets in space exploration. Electronics is just beginning to tap its potential as a vital and essential tool for industry, commerce, education, the farm, and the home. New products, new markets, and the pressing need for plant modernization should push electronic sales to another record in 1964.